In this video, I'm going to give you a step-by-step solution to physics midterm. This video will be less than 20 minutes long. That means I'll spend less than 1 minute to solve each problem. Problem number one, I ask you, I wanted to verify your understanding between the scalar and vector quantities. So here's what I ask you: a unit used for vector quantity. To remind you, there are two types of quantity: vector, scalar, and vector. Scalar give you one information, magnitude, and vector give you two information, magnitude and direction. All right, so I gave you four options. Number one, I gave you a gram. Number two, I gave you kilogram. Number three, I give you Newton. And number four, I give you second. These all four are unit. This is SI unit for mass. This is SI unit for time. This is SI unit for force. This is not SI unit. This is just unit, but not SI unit. This is scalar. This is also scalar. This is vector. That was the problem number one. That takes us to problem number two. You have a mass which is a 4 kilogram accelerating to the east. How much? Let's say 10 meter per second square. Okay, because why it is accelerating? Because there is applied force, let's say 50 Newton. We want to find the force of friction. Now the way I draw force of friction is wrong, because if there is an acceleration, there must be a net force. Net force is this direction at the east, at the direction of the acceleration. So this must be bigger than this one, and let's make that happen. So now it's good. So you're gonna start your conversation with Newton's second law. All the forces acting at the x direction, Fa minus Ff is equal to m is 4 kilogram and acceleration is given 10 meter per second square. To the east means positive. Fa is 50 Newton minus Ff is equal to 4 times 10, 40 kilogram meter per second square is Newton. 50 Newton minus 40 Newton is equal to Ff. Now we have our final answer. Ff is 10 Newton. So this is 10 Newton. So what is the net force at this direction? The net force at this direction is, of course, 50 minus 10, which is 40 Newton at the direction of the acceleration. That takes us to problem number 3. So that takes us to problem number 3. That has to do with two cars. There is a road and the car number A. So this is car A and this is car B. So let's say this is at right here, the time is the car A, the time is 0, distance is 0. The car 2 have head start 200 meter, and then right here at location, let's say right here at location L, they both meet. The red car and the black car, this is car B, red and black, they both meet at this location. All right, what we want to know, how far this one has to move so that it meets with the car B. What do you know? We know this car can move with 20 meter per second and this car can move with 15 meter per second. All right, this car, although is behind, it will catch up this one. Why it is going to be catching up is because this one moves faster, but it's not going to be catching up almost immediately. Is because 200 meter, it takes time for this one to complete 200 meters. Eventually it's going to be catching up. At this location they're going to meet. What location is that? Let's find it out. Let's do this one first. D is equal to VIT plus half AT squared. Again, D is equal to VIT plus half AT squared. Now this D is equal to VI is 20 meter per second, T, this is 0, this is D is equal to 15 meter time, this is 0. All right, that's not it. This one has head start, how much? 200. All right, now we're gonna say at this right here the red is equal to black car. It's the same right there. Red car is equal to black car at that location. What does that mean in mathematics? Well, it means D is equal to D. What does that mean? 20t is equal to 15t plus 200. What does that mean? 5t is equal to 200, so t is equal to 40. So now if you come over here, 20 times 40 is 800. So this one has to move how long? From here to here is 800 meter, because right here 800 meter from here it's gonna meet with the other car. That takes us to problem number 4. Problem number 4, I still see some of you are suffering from the heavy object and light object. When you change the mass from light to heavy, some of you still think that this will somehow affect the displacement of a falling body and velocity of a falling body, but they don't. Galileo hypothesized that 1590 when he was only 26-year-old, about 400 years ago. In the year 2023, we should not be suffering from this misconception. Number 4, let's consider a light object and a heavy object, okay, and let's consider their displacement at the end of 1 second and at the end of 2 seconds. All right, acceleration due to gravity, of course I'm going to use -10 meter per second square. And let's consider the heavy mass versus light mass, velocity at the end of 1 second and velocity at the end of 2 seconds. All right, displacement at the end of 1 second for the light object is of course 5 meter, and this one also 5 meters. This one is 20 meter and this one also is 20 meters. This one is 10 meter per second at the end of 1 second. This one is 10 meter per second at the end of 1 second, of course down. This one is 20 meter per second down, and this one is 20 meter per second down. Now you probably think, what if you make this mass is smaller and this mass is even bigger? If this could be 1 kilogram and this could be 100 kilogram, still this is going to be the same. This could be 1 kilogram and this could be 1000 kilogram, and this is still going to be the same. Why is that? Because hey, D is equal to VAT plus half AT squared at the y direction, of course. So now if you do the math, what do you get? You get this one is 0. Why? Because you drop it. And this is dy is equal to what? Half this is negative 10, and this is t squared at the end of 1 second. So this is 1 squared, this is 1, so this is just negative 5. Proof. Let me prove this one. For the heavy object, Vf is equal to Vi plus At, of course at the y direction, because it is falling at the y direction. So this one is 0. So this one is negative 10 times 1, because it's end of 1 second. So of course it's 10 meter per second down. Okay, so mass has nothing to do with object velocity and object displacement when it is falling, because it's free fall. So let's go problem number 5. It's a free fall problem. So there are 3 types of free fall, as you can recall. Number 1 is just drop, number 2 is throwing up, and number 3 throwing down. This one is throwing down. Throwing down has a name. The velocity must be less than 0. In this case, velocity is you throw it down from the top of a 4-meter building with initial velocity 0.5 meter per second. Okay, and you want to find the velocity of the ball at the end of 0.7 second, at the end of 0.7 second, and that's what you want to find. Now conceptually, you know that when you just drop it at the end of 1 second, it falls 5 meters. Okay, now you're probably thinking at the end of 0.7 second it already falls 4 meters. Why? Is because it starts with some initial velocity, and that helps, that makes it faster. Alright, so how that works, let's see. Vf is equal to Vi plus At. So Vf at the end of 0.7 second, V initial of course is negative 0.5 meter per second plus minus 10 meter per second square, and then 0.7 second. All right, so second square second. So Vf is equal to, you have 0.5 meter per second minus 10 and then the 7, so you have just 7 meter per second. So you have Vf is negative, this is negative 7.5 meter per second, and they ask you to find the speed. So you're gonna make it a speed. So speed is, of course, you take the absolute value of 7.5 meter per second. Of course, I did not probably give you 7.5, I gave you 7.4, but this is very close to 7.4, so therefore this is the answer. However, how much you can fall at the end of 1 second when it is at the end of 0.7 second when it is free fall. When it is free fall, then Vi plus At, this is 0 because you're dropping. If you drop it, this would be negative 10.7, so it's gonna fall only the velocity final will be 7 meter per second. Now its velocity final is 7.5. That makes sense because this is started with some initial, and that is 0.5, of course. Problem 6, if you read carefully, you'll notice that it's also a free fall problem. So you throw a ball upward. You throw a ball upward with some initial velocity, which I did not give you. However, I gave you the max height. The max height of the ball is, I gave you 20 meters. I want you to find the speed over here, final velocity. You know V initial is equal to V final. All right. So if you take the absolute value, that becomes the speed over here. Very simple. So now what do you know about it? Vf squared is equal to Vi squared plus 280. This equation always work when it comes to solving a problem with a maximum height. Velocity, of course, over here is 0. Make it y everything, because we have to do with maximum height, and this is your maximum height. V I y is what you're looking for. You're looking for this one. Plus 2, negative 10. Acceleration due to gravity is negative 10. And dy is 20. So 0 is equal to vi y squared minus 20 times 20 is 400. So minus vi y squared is equal to minus 400. Minus minus cancel. So vi squared is equal to 400. So v is equal to square root of 400, which is 20. So vi is 20. Okay, so vf is negative 20, because of course this is equal in magnitude, opposite in direction. Absolute value is the 20 meter per second over here, the final speed of the ball in this throwing up, which is also a free fall problem. Number 7 is also a free fall problem. You are on the top of a building which is 50 meter, and you throw a stone with the horizontal velocity vx is 4 meter per second, right? And how long the ball is in the air, how long does it take for the ball to hit the ground? So you're going to find the t over here. So of course this information useless. You're not going to use this information. I was hoping that you're going to use this information, but if you do use this information, that's not good. What you're going to use is vy here at the top when the ball is rolling off the rooftop with 4 meter per second, and that is of course 0, and that is what you need to find, of course, the time. So d is equal to vit plus half at squared. So d is negative 50. This is at the y direction, 0. Half negative 10, of course, t squared. Negative 50 is equal to negative 5t squared. So then t squared is equal to 10. So t is 3.2. You can solve this problem many different ways. This is just one way. So at least solve this problem at least 4 or 5 ways. All right. Number 8 is just like number 6. It's a free fall problem. What happened? I throw a ball in the air. Okay. When I throw a ball in the air, it creates a trajectory just like this, and I gave you one which is like this, and number 2 which is like this, number 3 which is like this, and number 4 which is like this. And these all are velocity versus time, velocity versus time, velocity versus time, velocity versus time graph. All right, so now we're going to verify which one is right. Okay, whenever I give you a problem like this, VT, make sure throwing off, you just immediately solve, you immediately draw it, immediately draw a throwing up. This is the throwing up. All right, so you have some initial velocity. Without initial velocity, you cannot throw up, right? And initial velocity, if initial velocity is more than 0, which it must be, let's say initial velocity is 5, final velocity has to be negative 5. So there is a initial velocity, there is a final velocity, and velocity on the top, Vy, of course, 0. Make sure you understand this thing. Now, if you convert this to a VT graph, what do you get? VT graph, right? Okay, initial velocity, let's say 5. All right, so let's say 5 initial velocity. Final velocity at some time t, or t equal to 2 seconds. This is your final velocity. Final velocity must be 0. Right here the velocity is 0. Over here this is equal in magnitude, opposite in direction. If this is 5, this has to be negative 5. So I'm not going to put the value over here. It doesn't make sense to put the value. this time is equal to this time, interval will be the same. So the graph will go, so the initial velocity with start with 5 or something, and then go down to 0, and then go up -5, and this is the graph. This is not the graph for something throwing upward, never. This one is the DT graph. This one is DT graph. So this is the only graph for problem number 8. Number 9, I gave you some pair of graphs and I asked you to find the graphs, pair of graphs that represent the same motion. So I gave you 4 options. Number 1, I gave you a DT graph. Number 2, I also give you a DT graph. Number 3, I also give you a DT graph. Number 4, I also give you a DT graph. Now, what type of DT graph I gave you? I gave you a parabola, and I gave you something like this. I give you a linear line like this. Number 3, I gave you something like this, and number 4, I gave you a parabola. All right, so now let's convert this one. All right, let's convert this one to VT graph and convert this one to VT graph. Convert this one to VT graph. Let's first convert this one VT. If this is a parabola, this has to be a diagonal line, as simple as that. This is positive, right? The slope of this one must be positive, right? And the slope of this one must be negative, right? It must be negative. So since this is a positive slope, I'm going to have a positive line. This slope is a negative, by the way, negative slope. So I'm going to have a negative line. This is a parabola, right? Upside down. This is when you throw an object upward, it comes back to where it is sourced from. So here initial velocity, here velocity finally 0. Here is equal to initial velocity, opposite in direction, equal in magnitude, opposite in direction. So what does that mean? That means like this, all right? But that's not what you see there. So therefore this is the correct, everything else is wrong, because this is not how I gave you. Number 10, two forces, two vectors acting on a mass, acting on a body with different angles, and we want to find, of course, the resultant, which angle gives the maximum resultant, or which angle gives the 52 Newton resultant. Okay, we know that the smaller the angle is, greater the resultant is. So you can do it conceptually, but you also can do it by math. Number 1, two vectors, 30 degree, right, 30 degree, and then and then maybe 60 degree, and then maybe 120 degree, and then maybe I don't know, 180 degree. All right, so you can do conceptually. The smaller the angle, the greater the size of the resultant. So this one would be the biggest, this one would be the biggest, this one would be the second biggest, this one would be the third biggest, and this one would be nothing. All right, okay. So if that's the case, now you can see that this one is, you know that this is 120 degree, means if this is 30 Newton and this is 30 Newton, which it is 30 Newton, 30 Newton, 30, 30, 30 and 30, and this one, you know, 30 by without doing any math. But again, you can use the math. R square is equal to A square plus B square plus 2AB cosine 30. So this is called law of parallelogram. So you have 30 square plus 30 square plus 2, 30, 30 cosine 30, and that's gonna give you 58. And how that's going to look like, that's if you draw a parallelogram, and this is the size, this is what we call 58 Newton, and that's not what I'm asking for. I'm asking for the resultant 52. So let's do this one. R square is equal to a square plus b square plus 2ab cosine, in this case 60, right? So r square is equal to 30 square plus 30 square plus 2 30 and then cosine 60, and this is going to give you r is equal to, of course, 52. Now how can you draw it? Of course you draw it by a parallelogram, and this is how your 52 going to look like, right? This one, without doing it, you know this is of course 30 because this is 120. So r square, I mean r is small, a square plus b square plus 2ab cosine 120, and that's gonna give you 30 square plus 30 square plus 230 cosine 120, and that gives you, of course, 30. And how would that look like? That would look like this, of course. This is 30. Okay, and this is 0. There is nothing going on. This is r is equal to 0, 30 minus 30. But hey, you can do the math. R square is equal to a square plus b square plus 2ab cosine 180. So r square is 30 square plus 30 square plus 2 30 minus 1. All right, so this is 0, right? So now the answer is, of course, I ask you to find 52. This you didn't have to use the math. You could have done it conceptually. I show you the math because, hey, when you in the future someday you're probably going to end up becoming a PhD candidate in physics. But 11 has to do with the range. I gave you the horizontal component of the velocity and the vertical component of the velocity, horizontal component of the velocity, vertical component of the velocity, horizontal component of the velocity, horizontal, and right here. Okay, so this one I gave you, this is 1, this is 2, this is 3, this is 4. I gave you horizontal component of velocity. I gave you 8 meters per second, and this one I gave you Vy, I don't know, 6 meters per second, and this one is Vx is 6 meters per second and 8 meters per second, and this one is 6 meters per second. This one is also 6 meters per second. This one is 8 meters per second, and this one is 8 meters per second. You definitely don't have to use the range equation. You don't have to use the range equation, sine 2 theta over g. You don't have to use the range equation. Why not? Because you can solve it conceptually, but I'm going to show you the math in case in the future when you take advanced physics. Is always and it's always good to support your conceptual understanding by math. All right, the big Vx always contribute to the big range, and the big Vy always contribute for the ball to stay longer in the air. Big Y means big elapsed time, so big Y, big Vy means big elapsed time, and big Vx means big range. So that one with big X gonna have big range, and big Y big elapsed time. That means you know this one, and 8 and tangent Y over X is 8 over 8, which is 1, which is 45 degree. So 45 degree, you know that give you maximum range. This is also 45 degree, but this one is a little bit better than this one. Why? Because this one is smaller and this one is bigger, so this one is going to be much better. But hey, this is our answer, but let's support it by math. Okay, so let's find the resultant. Make it vector, 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 make it vector. Resultant, this is 90, 90, 90, 90. So you can find the resultant pretty quickly. So let's say this one is 10, 64 and 36. Yeah, 64, 36. So this is 10. This is 8.5. 10, 10, 8.5 and 11.3. So this is 11.3. All right. So now you want to find the angle. So tangent is Vy over Vx. Vx. So the theta is, this one is of course tangent inverse. So the theta is tangent inverse Vy is 6 over 8. So theta is 37 degree. This one is gonna be all right. So again, tangent is theta is tangent inverse 8 over 6, right? 8 over 6, and this is gonna give you 53. And this one theta is tangent inverse 6 over 6, which gives you 45 degree. And you know that because I gave you the unit circle. At unit circle 45 degree, this is square root of 2 over 2, and this is square root of 2 over 2. The both component is the same. When both components are the same, what happened? Square root of 2 over 2 over square root of 2 over 2 is equal to square root of 2 over 2 times 2 over square root of 2, and that is 1. So 45 degree always 1. Even if you don't have calculator, you know this is 1. Theta is equal to tangent inverse 8 over 8. So theta is 45 degree. Okay, so now we know the angle. So this is 45 degree, this is 45 degree, this is 53 degree, and this is 37 degrees. So we can erase this to do the range equation. All right, so now we're going to do the range equation and to see how much it is. Okay, so R is equal to V square sine 2 theta over 10. So V square is of course 10 square sine 2 theta, which is 37, 35, 70, 74 over 10. So R is 9.8. So this is gonna 9.8. So this is 9.8 range. Okay, so now this one, let's see. R is equal to V square sine 2 theta over 10. V square is of course 10 square sine 2 theta is 106. So this is also 9.8. So what happened? This and this would be the same, 9.8. All right, let's see this one. R is equal to let's see 8.5 square sine 90 over 10. So 8.5 square is sine 90. Sine 90 is 1. So over 10. So this is not quite 100. So this is 7.4, 7.3 is 64, 7.3, 7.4, not sure. All right, so this is smaller than this. This is 9.8, by the way. This is smaller than this, 7.3, because this and this are smaller than the others. Okay, so this one is R is equal to V square, which is of course 11.3 square sine 90 over of course 10. So this gonna give 13. So now let's go ahead, and so this range is 13. So this give you the biggest range, and then the second, and these two are the second, and this one is the third. Problem number 12. Problem number 12 is a trigonometry problem. So there is a box, and someone pulling the box with 22 Newton at 35-degree angle. We want to know what is the force of friction. That's it, very simple. I did not give you what type of material it is. I did not tell you how many kilogram the box is, but one thing I told you, and that is the box moves with constant velocity. What does that mean? That means in a friction graph, constant velocity is b if this is ff and this is fa, right? What does that mean? It means constant velocity. The thing is moving without acceleration, so acceleration must be zero. Acceleration must be zero. So net force must be zero. Net force at x direction must be zero. Of course, y direction, ball is not going to the air, the box. Okay, so now we know that ff is equal to f. This is applied, f applied x, right? Okay, and what is that? So fa has two components, right? fx, fy. Fx is 22 cosine 35, and this is 18, and this is 22 sine 35, and we don't need to know this one, so this is 18. So ff is fax, and this is 18 Newton. So fff is 18 Newton. Okay, so if this is 18 Newton, what is the net force at the x direction? At the x direction, this is 18 Newton, and this is 18 Newton. 18 Newton. So the box is in equilibrium. Why? Because net force is zero. The box is in equilibrium. Why? The acceleration is zero. Why is that? Because 18 minus 18 is 0. Last multiple choice problem, number 13. You know, the soccer field is about 100 meters, but the basketball field is about 30 meters. So during the basketball practice, a player run from location A to location B from one end to the other end, which is of course 30 meters, and he does it 3 times. So if we go to B, so A to B, I can write better. I never get tired. A to B is 30 and B to A is 30, and he does it 3 times, so 180 meters. All right, that's how much he moves. That's how much the distance he moves. But of course his displacement is 0, and thus we don't care about the displacement, because I ask you to find the speed. The velocity, his velocity would be 0, because velocity is displacement over time. He does it using, of course, 60 seconds, right? So his velocity is 0. His speed is not 0. So his speed is distance over time, not the displacement. Distance is 180, and the time is 60. So the speed is 3 meters per second. I gave you a dt graph, and I asked you to convert it to a vt graph. So here's what I gave you: a dt graph, a 10-second long dt graph. So this is 2, this is 4, this is 6, this is 8, this is 10, and this is let's say 4, this is 8, this is 12, and this is 16, and this is distance or displacement. We're gonna do it both ways. So let's quickly put them in section. From 0 to 4 seconds, the object has velocity of, I don't know, let's see, 8 minus 0, 8 divided by 4, which is 8 divided by 4, 2 meters per second. That's the velocity. From 4 to 6, object has no velocity. From 6 to 8, object has acceleration. And from 8 to 10, object has acceleration. All right? Okay. Now, we're going to convert it to VT graph. Of course, this is 4, this is 6, this is 8, this is -2, -4, -6, -8. So, from 0 to 4. So 0 to 4 is 2 meter per second. All right, from 4 to 6 is 0 meter per second. All right, and what is the velocity over here? Let's see. The velocity over here, this is a parabola, so parabola will become what? A triangle. So a triangle has half base times height is equal to d, displacement. Half base is from 8 minus 6 to height is, we're going to try to find, height is the velocity. We're going to replace it with velocity, and d is, we know that 16 minus 8, which is 8, 2 to cancel. So velocity is 8. Right here velocity is 8. So 8. Okay. Right here velocity is 0. All right, at 8 velocity is 0. Right here velocity must be negative 8 because it's equal in magnitude, opposite in direction. So negative 8 should be right here. Okay, so I'm just going to use a ruler to connect this one because it looks tricky to connect. All right. All right, so this area and this area, so you're going to add them up. We're going to find the distance and displacement both. All right, so this area BH, because this is a rectangle, so B is 4 minus 0 and H is 2, so this is 8. So this area is 8. Okay, this area is 8. This area is 0 because there is nothing going on over here, because 6 minus 4 is of course 2, and height is 0 because the velocity is 0. So 2 times 0 is 0. So this one is 0. You're going to do this one now. Half BH. Half B is 8 minus 6 is 2 and H is 8. 2 to cancel, so this is 8. And this is half BH. Half B is 10 minus 8 to H is negative 8. So this is negative 8. So our displacement is 8 plus 0 plus 8 plus minus 8. So 8 cancel. So our displacement is 8. Our distance, absolute value of 8 plus absolute value of 0 plus absolute value of 8 plus absolute value of negative 8. So our distance is 24 meter and displacement is 8 meters. I gave you two vectors, and vector 1 is 80 Newton, which is perpendicular to vector 2, which is 60 Newton. Let's call it vector A, let's call it vector B, and I wanted to find the angle between the north and the resultant. Okay, so how do you know the resultant? Without the head and tail, you know this is the resultant, and the 60 squared and the 80 squared is the Pythagorean theorem I'm going to give you, because this is 90 degree. Even if you use the lob sine, lob cosine, parallelogram, everything going to give you same. But why would you can use the Pythagorean theorem? So r squared, or r is 80 squared plus 60 squared, so r is 100, right? So this is 100. You can find the resultant like this, or you can draw a parallelogram. So this is tail and tail, tail and tail, head and head. So the resultant gonna go start from tail to tail and end at head and head. That's how you're gonna draw the resultant. All right, so this is how you can draw the resultant. And this is R, this is 100 Newton, of course. I did not ask you to find this angle. I did not. But if you do find this angle, you know this one. That's how it should be. So you know that the TOA, so the tangent theta is opposite. So what is opposite? Opposite is 80. So 80. And hypotenuse is 60. So theta is tangent inverse 80 over 60. Alright, so the theta is 53. If this is 53, then 53 plus x, this is x, is equal to 90. So x is equal to 37. So I don't even want you to show me this, because that's not what I want. I want the resultant and north. So this is resultant, this is north, and this is 37. Okay, and that's it. That's all I want. I don't want even the size of the resultant. Even if you write 37 over here, that's also okay. Now I'm going to go over the last problem. Back and forth. So let's say this is A, this is B, and we did it before. A to B is 30 meter, back and forth. So 60 meter, he did it 3 times, so 180 meter is spending 60 seconds. So the total speed is of course 180 distance divided by time. 180 divided by 60 is 3 meters per second. All right, so what I want you to do is dt, vt, and at graph. So let's do the dt first. Dt, and this is 180. How much second? 60 second. All right, so now we're gonna do st. If you do st, since this is a diagonal line, this become a horizontal line. The time is 60 seconds and the velocity is 3, and the distance is gonna be bh. So b is 60, h is 3, so 180 a meter, and that makes sense. All right, now we're going to do the displacement versus time graph. Here's how I'm going to do it. So the first 30 minute, the first 30 meter, the total trip is 60 seconds. So the first 30 meter, this is the first round. We're going to say A to B. Wait, I'm going to say it. So A to B, A to B, A to B. It takes him how long? 10 seconds, right? 10 seconds. All right, so A to B, it takes him 10 seconds. Okay, and this is of course displacement versus time graph. Okay, and then B to A, this is another 10 seconds. All right, so this is B to A, so this is 10 seconds. This is 10, this is 20. Again A to B, another 10, so this is 30. B to A, 10, 40 seconds. A to B, 10, A to B 10, and B to A 10, altogether 60 seconds. And this is 50 and this is 60 seconds. All right, and the displacement is, of course, this is 30, right? Okay, so I'm going to draw a velocity versus time graph, VT. So let's do, this is A to B, A to B, B to A to B, A to B, A to B, B to A, B to A, B to A. Okay, now let's do this one, A to B again, A to B again, and so on. That's it. So now let's put the time, right? This is 10, this is 20, 30, 40, 50, and then this is 60 seconds. And of course this is 3 meters per second. And then this has to be negative 3 meters per second. Alright. So this one is BH. So this is 10 times 3 is 30. So this is 30. This is negative 30. This is 30. This is negative 30. This is 30. This is negative 30. So 30 negative 30 is 0. 30 negative 30 is 0. 30 negative 30 is 0. So total displacement would be 30 minus 30 plus 30 minus 30 plus 30 minus 30. So total displacement would be 0, and that makes sense, right? So this is what I was looking for, dt st, displacement versus time, velocity versus time.